Hi, this is Jason Baker, and welcome back to our lecture. In the previous lecture segment, I showed you how you could use Ansible in an ad hoc manner to run commands against remote systems. The second way we can use Ansible is we can use it to execute playbooks. And if you remember, playbooks are basically YAML files that contain configuration code, and that code describes how a system should be configured. It describes the desired state of a system. And playbooks are probably the most common way to utilize Ansible in your organization. So let's start looking at playbooks and seeing how we go about composing a playbook. And I'm going to start with providing you a demonstration. And this is, we'll start with something really easy. I'm going to go to the shell and I'm going to run this ad hoc command. So I'm going to run the Ansible command against all hosts. And I'm going to run the shell module and provide it an argument. And the argument is I'm basically a shell command, which is simply going to echo out the words hello. This is like a very simple hello world script that you might find in any programming language. Now I'm going to run this on my local machine, and so when I tell Ansible to run it on all hosts, the only host that I have defined in my inventory file is my local machine in this case. So I'm going to say Ansible all. I'm going to tell it to run the shell module and give it the argument echo hello world. And I'll run that command and I get a success. Ansible runs that command and it echoes out hello world. That's exactly what I expected it to do. Now, instead of running this command in an ad hoc manner on the command line, I can instead create a playbook. And the playbook is just a YAML file. So I've already created it. It's called hello world.yaml. I'm going to take a look at this file, and you see that the the YAML file contains one play. You can see that because each play is a member of a list. So you gotta think of the YAML file as being sort of like this hierarchy. And at the top level of the hierarchy are plays. So each play is a is a list element. And so that's and list elements in YAML files are preceded by the dash character. So I have a list element defining the play. The play is going to run against all hosts, which again, in this case, on my system, there's only one host that's in the inventory file, which is the local host. And then each play will specify a list of tasks to run. And in this case, there's just one task. And the task has a couple different elements. There's a name property for the task. And you'll see how the name property is really useful because when Ansible outputs the running of this playbook, it will output the name of the task that it's running and then the associated output of the task. So the naming your tasks is a really good habit for just for sort of basic debugging purposes. And then the second element is a module that I'm calling, and I'm calling the shell module, and I'm passing in the arguments echo hello world. So let's go ahead and run this. Well, in order to run this, we don't use the Ansible command. We use a slightly different command called Ansible playbook, Ansible-playbook. And I'm going to pass in the -v option, which stands for verbose. I want to see the actual output of the shell command that's being run within the playbook. And then I just give it the name of the YAML file that I want Ansible to play. And I hit enter. And the first thing that Ansible is going to do is it's going to set up the tasks. It does this setup process and before it runs the tasks in the playbook. And then it has actually run the task. And you can see here it says it gives me the name of the task that it ran. That's because I gave the task a name. And this is where I mentioned this is helpful for troubleshooting purposes. And then it gives me the output of this task. Because I passed in -v, it will give me the standard out, which is this, so it's outputting a JSON, basically it's outputting a JSON object here, and there's a standard out key within that object, and the value of that is the actual output of the shell script command. So if I wanted to, I could go ahead and modify this. Now let's go ahead and modify it to add another task. To do that, I'm going to add another list member because remember the different tasks are each task is essentially a list element. I'm going to give it a name. I'm going to call it system uptime. And then this is going to be another shell command, and we're just going to use the uptime shell command. I'll save that, and then I'll run the playbook again. It's going through the setup process, and it will now run my two tasks. So you see a task run shell command and a task system uptime, and you can see the standard output from each of these tasks. And then other thing I'll note is at the very end of the playbook, it gives you this recap. It tells you that it ran 3 tasks. The first task is a setup task, and then it tells you what changes were made. Anytime you run a shell script command, that's considered a change, even if it didn't actually change anything on your system. Technically, it did change something because you ran that command and there was likely a log file entry written somewhere in your system. So there was an actual system change, even though running the shell script command itself didn't change any, it didn't change the configuration of a service or add software or anything like that. So that's a quick example of how you would create a YAML file, a playbook, and how you can add plays and add tasks to the playbook. Um, Another thing to keep in mind when you're running this Ansible playbook command is that you can specify a parallelism level option when running the command by passing in the -f argument. So you can tell Ansible that you want it to run this playbook in parallel against multiple systems simultaneously. Maybe you want to run a play against 100 systems in your environment, and you want Ansible to run that play against 10 systems at a time. You can do that by passing in this -f and then passing in the number 10. And that tells Ansible to run the playbook against up to 10 systems at once. A handy feature. So our playbooks are what we use to describe the desired state of a system. The playbooks are declarative in some sense, but they also allow us to orchestrate steps of really complicated ordered processes that we can do complex orchestration tasks. For example, we might have an environment where we're launching web application servers and we're launching database servers. We might want to launch the database servers first and then dynamically determine the database endpoints and pass those in as variables into the web server or the web application server configuration. And Ansible can do that. So Ansible can go out and configure our database servers and then provide our and then go out and configure our web application servers and provide the web servers with the credentials that Ansible used to build the database servers. So you can set up fairly complex orchestration architectures using a tool like Ansible. Now, we don't do that in this class, but I just want you to be aware of the fact that you know that you can do very complicated things using this tool. Each playbook that you create will contain one or more plays. And when you're defining a play in a playbook, you need to define a host target. And that's provided by this hosts parameter. And the hosts parameter tells Ansible that it should look up a group of hosts or a host in the inventory file. And it should run this play against a particular host. You could have a playbook that has multiple plays, and each play is running against a different host or different group of hosts. That's perfectly acceptable. And like I mentioned earlier, if you're doing really complicated orchestration sort of tasks, then that's one of the ways that you would do it. Also, when you're defining the play, oftentimes you'll specify a remote user, and that's using the remote underscore user parameter. And that remote user parameter tells Ansible the username that it should use when it's logging into the remote host. Remember, Ansible is using SSH under the hood to go out and connect to remote servers and run these tasks and run these modules within a play. So Ansible needs to be able to shell into a server just like you need to be able to shell into a server. So it needs a username. It might also, in some cases, need a key to also access the remote server. Sometimes we want to run tasks in a play that require root access in order to execute properly. For example, if you want to install software using the yum module, maybe you want to install the Nginx software package, you know that in order to install a new package like that on a system, you need to have root level privileges. And the same is true for Ansible. It has to obey the same security rules that any other user in the system would follow. So in this example, Ansible is logging into the remote server using the EC2-user account, and it will become a privileged user. That's what this become parameter specifies. So we say become yes. That means that we want to become a privileged user. And in this case, we're also specifying the method in which we're going to become a privileged user, which is using the sudo method, which is probably the most common way to become a privileged user on a Linux system. So now Ansible will run these tasks. You see, there's two tasks here. It will run these tasks as the sudo user. Now, one very common mistake I see students make every semester is that what they'll do is they will create a separate play for every single individual task. And then they'll specify, this become yes and become method sudo for every single task. You shouldn't do that. That's a really bad practice. What you should be thinking about is how do you group tasks together? You want to group these tasks together because you've got some overall objective, right? The objective of your play might be to install and configure a web server. And so you don't want to create separate plays for every single task. You just simply need to group those tasks together. All the tasks that are designed to accomplish the objective of building a web server, those all get grouped together under one play. And each task is essentially a list element. And because we've said that we want to, when we run this play, we want to become a privileged user, then every single one of these tasks will run with the privileged user access. So we have a playbook. A playbook is comprised of one or more plays, and then each play is comprised of one or more tasks. The tasks that we specify in a play are executed in order, one at a time, from the top to the bottom. And every host that we specify in our playbook, every host that's matched against our playbook, is going to receive the same set of tasks. Now, if let's say that we're executing a playbook against a particular host. Let's say we have a group of hosts we're executing a playbook against. And when Ansible is running the playbook on one of those hosts, one of the tasks fails on the host. So if a task fails during the running of a playbook, then Ansible basically stops the execution of that playbook on that particular host. Every task that we define within a play will execute a module. And remember, a module is a little Ansible helper application that performs some particular configuration task. It might be running a shell script command, it might be installing software or starting up a service. And every time we execute a module, we're passing in some arguments, and the arguments are going to change the way that the module executes. Some of those arguments could be variables, and so variables allow us to dynamically change how a playbook or play or task executes. Modules are idempotent, which means that we can run the same task over and over again and generally achieve the same result, the same desired state. You saw that in a previous lecture segment where I ran an ad hoc command multiple times, and you saw that after I ran the command the second time, it didn't do anything because there was nothing that needed to be changed on the system configuration. Every task that you define in a play should have a name, and again, that's primarily for troubleshooting purposes. It's included in the output when you're running the playbook, and it's a good habit to get into. So we have a task, so tasks are defined in the tasks section of a play, and each task is a list element, and the task begins with might begin with a name, and a description, and then each task is specified using a module and then a set of arguments. And the arguments oftentimes can be these key value pairs. So for example, in this task, we're telling it that we want to use the service module, and the service module will ensure that this service, HTTPD, which is Apache, that this service is in a started state. The command and shell modules don't take a standard list of key value arguments. They just take a list of shell command arguments. So in this case, we're running a shell command, which is the set and force command, and we can pass it in just like we were passing it in, almost like on the command line. And I also mentioned that tasks can use variables as arguments. Here's a case where a task is using the template module, which I'll talk about here in a bit, and we're passing in a variable. This variable is designated, it's enclosed between these double curly brackets, and that specifies a variable in a playbook. There are a number of different modules and commands that we can use when we're specifying tasks. One interesting argument that we can provide is or parameter we can provide is the include parameter. And the include parameter allows us to include other files within our playbook. So it allows us, you can think of this as like, imagine you were creating some smaller plays that are sort of like building blocks, and we can include those playbooks within other playbooks. Here's a case where we are including another YAML file, the foo.yaml file, and we're going to include it into this task. So this YAML file probably is defining a number of tasks. Here we're including these files again, but we're also passing variables. And so there's going to probably be some variable interpolation when that included code is sort of merged with this parent playbook. Here's an example where we're including one playbook file into another playbook file using include. We don't use include in this class, but again, it's a pretty common pattern for you to use when you're building more complex playbooks. And so I just want you to be aware of the fact that you can include snippets of code or playbooks inside of other playbooks. I mentioned that you can use variables within playbooks, and variables allow you to deal with the sort of small configuration differences between systems. For example, maybe you have two different web application servers where 95% of the configuration of those servers is the same, but there's maybe some small difference. Well, it would be kind of a waste to build two playbooks that are almost identical, except for maybe like one particular configuration difference. Instead, you can use variables, and you can use variables to dynamically change the way a playbook is run on a particular system. When you define variables within Ansible, they should always be include letters, numbers, and underscores. Variables must start with a letter. And when you define variables in YAML, you can do all kinds of interesting things. For example, you can set up mappings in variables. So here we have a variable called foo, and that foo variable is going to have two mappings. This is sort of like a dictionary object. So it has a mapping with a key called field 1 and a value called 1, a key called field 2 with a value of 2. Then if I want to reference this mapping in my playbook, I can just call the foo variable and then pass in the key. There's two different ways. You can use a dot notation to do it, or you can specify it as the key as a string value between square brackets. You can define variables directly inside of a playbook, and you do so in the vars section. So you have within your play, you've defined the hosts, and you can have a vars section, and the vars section can contain a set of key value pairs. So here's a variable called HTTP underscore port, and this variable, this variable has a value of 800. I mentioned in one of the previous lecture segments that Ansible can store facts about a system. And a fact is basically a think of it as like a variable that describes some property of a remote system. And a property could be a lot of different things. It could be like the name of a system, the IP addresses and network interfaces on a system, the operating system version, the amount of memory on a system. All these facts are discovered automatically using the setup module. And these facts are then stored in a big JSON object. And this JSON object is something that Ansible can actually access when it's running a playbook. You remember earlier when I ran the playbook, there was this sort of initial pause during the running of the playbook, and it was running this setup task. Well, what Ansible is doing is it's actually discovering facts about the system, and because it might need to use these facts when running the playbook. If I go back to my command prompt, if I just run the command Ansible all dash module, I'm going to run the setup module. And this is the module that Ansible is running when it does the setup process within a playbook. Right now, it's actually gathering all the facts on my current local system. And once it's retrieved those facts, it's going to output them. So here you can see the object, and it's this massive JSON object that contains literally hundreds and hundreds of different properties on my running system. Just about anything you can imagine on my current system is described in this JSON object. So it describes all the network interfaces, it describes hardware information, it describes the name of my machine, how much memory is on the machine. It describes like different software packages, tons and tons of different information. So it's gathering facts about the system. And every system that Ansible runs a playbook against, it's going to gather facts about that system first. So what Ansible can do once it's gathered facts about a system is it can actually reference those facts within a playbook. And it can reference them just as if they were just as if they were defined like any other variable in our play. The Ansible facts are the variable names are prefixed with the Ansible underscore name. So for example, I could use a fact in a play like it's surrounded with these double curly braces, Ansible underscore architecture. And the value of that variable then would be x86 underscore 64. So, so why would you want to use facts? Why would these be useful? Well, because again, we might want to execute a playbook in a certain way, depending on the type of system that the playbook is running on. We might have an environment where we have different types of Linux servers. Maybe some of our Linux servers are running Amazon Linux, and maybe some of them are running Ubuntu Linux. Well, you probably are, if you remember, there's two different ways that you can install packages on systems. And Amazon Linux uses yum, and Ubuntu uses apt-get. So you wouldn't want to run the yum module on an an Ubuntu system. So if you were installing, if you wanted to create a playbook which could install software on both Amazon Linux systems and on Ubuntu systems, you would need a way, your Ansible and your playbook would need a way to determine what kind of system it's running the playbook against. And so that's where the fact comes into play. Ansible will retrieve facts about the system, and looking at one of those facts, then it can determine whether or not the system is an Ansible is an Amazon Linux or is an Ubuntu system. And then based upon that fact, it can then choose the correct method to install software on that particular system. Very, very handy feature. So I've talked about variables, how you can define these key value pairs and use them within your playbook. You can also define a special kind of variable called a registered variable. And these are really useful because registered variables allow us to store the output that's returned by executing some sort of command. Here's an example where we have a task, and this task is going to run a shell, in this case it's a shell script called user bin foo, and we're creating a register variable. So we specify a register variable by using this register element, and we specify the name of the register variable we want to create. When this shell script runs, the output from this shell script then will be stored in the foo underscore result variable. We can then reference that variable later on in our playbook if we wanted to use it for something. So maybe we run a command on a system, and we need to use the output of that command as an input to some other command later on in our playbook, and that's why we would use something like a register variable. We can specify and use the template module within tasks. The template module allows us to dynamically create configuration files and use variable substitution to build configuration files. And this is a very, very common pattern when we're managing the configuration files associated with services on a system. So for example, we might have an Nginx web server that we've installed in a system. The Nginx web server uses a configuration file called the nginx.conf file. And so you could specify exactly what that nginx.conf file should look like, and then just sort of copy the file into the correct place on the system. But a better way to do it is to turn the nginx conf file into a template and then use the template module to manage the building of that file. So here's an example where we have an nginx.conf file. It's, in this case, we call it nginx.conf.j2. The Ansible uses a templating language called Jinja 2. So that's where the .j2 name extension comes from. So here's our nginx configuration file. And you see in our configuration file that we have a number of variables. We have a couple of variables that are specified. So variables are encapsulated by these double curly braces. You can think of these variables as being like, these are sort of like temporary values. These are placeholders within our template. The template module will load this file, and then it will substitute these placeholder values with the actual variable values. And then it will create a new file. So it's literally using these as placeholders within a template. Here's an example of how we might use this module in a task where we are specifying a template. We specify the source template, which is nginx.conf.j2, and then we specify the destination template. So Ansible will use the template module to load in this template, and then it will replace these variable names with the associated variable values. Where are the values coming from? Well, the values are defined somewhere earlier within the playbook. They're either like key value pairs that we've explicitly defined in a vars section of our play, or perhaps maybe we're using facts, and so they're Ansible underscore variable names, and these are facts that are generated by the initial setup process that the playbook runs through. When you're setting up these placeholders within an Ansible template, the Jinja 2 templating language allows you to set up a number of different filters that you can use within a template. For example, when you're setting up one of these placeholders, you might want to define a variable for that placeholder. But if that variable doesn't exist yet, or you haven't specified a value for that variable yet, then maybe you want the template module to use a default value. So you can do that by using this syntax. You have variable name, then the pipe, and then you can specify a default value for that particular placeholder. You can define a list of values and pipe it into a max argument here, and that will, and the template module will select the maximum value from a list of values. You can pick a random number from 0 to 10 using this random argument. And then you can do some concatenation. You can do a test on a string. So this is just a small selection of the different filters that are available to you. Again, it's very, very common for us to when we're working with configuration files for services on a system, we try to turn each one of those configuration files into a template. because then that template becomes reusable. We can reuse that template across multiple systems, maybe even across multiple playbooks. And because all we need to do is just plug in the right values, we set the correct variables, and we can then reuse that template on all kinds of different systems. We can define conditional statements within playbooks. There are a couple different ways to do that. One common way is to use the when statement. And the when statement is defined as part of a task. Here you can see there's a task. And so we have a list element. The task has a name. And then we're using the command module to run a shell command. And this shell command or this task will be executed by Ansible when this particular condition is true. So when the Ansible OS family equals Debian, then this task will be run. If this task evaluates to false, then Ansible will actually skip the running of this task. And remember, because this variable name starts with Ansible underscore, this means that this variable is a fact. And because we're using the variable within a when statement, we don't have to enclose the variable name with the double curly brackets. There might be cases when we want a particular task to run when multiple conditions are true. In that case, we can specify the when statement and then provide it with a list of conditional statements to evaluate. So you can see that this one is using Ansible distribution equals CentOS and Ansible distribution major version equals 6. So this statement will be executed when it's running on a CentOS version 6 Linux system. We can loop over tasks within a play. Sometimes we need to perform a task multiple times within a play, and I suppose you could like copy and paste the task multiple times, but that's not very efficient. That's not a very dry way to be programming your Ansible playbook. A better option is to loop over a set of tasks multiple times, and we can do that by using the with items directive. Can use the with sequence directive to loop over a set of tasks, and it's essentially generating a sequence of tasks automatically for us. Here's an example where we want to run a task using the file module. And this file module is going to create a directory. So you can see it says state equals directory. The directory it's going to create is called var stuff, and then we're passing in a variable called item. And this is a special variable that's being created for us by the with sequence directive. So we also pass in the with sequence directive, and we start the sequence at 4, end it at 16, and use a stride of 2. Stride means a step. So when Ansible runs this sequence, it's going to start at 4, and then it's going to step up to 16 in steps of 2. So it'll go 4, 6, 8, 10, 12, 14, 16. And each time it's stepping through that sequence, it's going to uh, assign that sequence value to this item variable. So what will happen here is that this file module will be called multiple times, and it will create a set of directories. So it'll create directories called var stuff 4, then var stuff 6, var stuff 8, var stuff 10, and so on. Sometimes when we're running a task, um, we we want to essentially retry a task until a certain condition is met. So we might want Ansible to keep retrying a task sort of over and over again until a condition is met on the system. So here's an example where we want it to run this shell script command. It's going to retry this command 5 times, a delay of 10 seconds between each retry, and it should keep retrying this up to 5 times until this particular condition is met on the system. So that's another way for us to sort of loop over a set of tasks. In this case, it's sort of retrying a particular task multiple times.